In this lesson, we're going to look at the cosine law. There are three different forms of the cosine law. They basically are all the same thing, but it depends upon what side or what angle you are looking for. So if you are either looking for angle A or side A, you would have one of the pieces of information, and then you would know the other two side lengths. Because it was A, or angle A, that you are looking for, this is the version we are using. Side A, angle A. If you look at the second version, we are dealing with B's on the end. So that would mean that you are either looking for angle B or side B. And if we look at the third one, we're dealing with C's. So in that one, you're either looking for side C or angle C. In this first example, we want to determine the length of CB to the nearest meter. CB is across angle A, so we can call it side A. 40 meters is across from angle C, so we can call it side C. And 32 is across from angle B, so we can call it side B. We are looking for side A, so we are going to deal with the version of the cosine law that looks like this. And what we do now is we substitute in the values that we know. We are looking for A squared. B squared is 32. C squared is 40. B is 32. C is 40. And A is 58. Find each of these values. 32 squared is 1024. 40 squared is 1600. Now, we want to make sure that we use our calculator properly. When we are finding sines and cos, we need to make sure our calculator is in degree mode. Very, very important. If you see an RAD or a GRAD, these are not the correct modes. You will not get the correct value for cos 58. You need to change it to degree mode. Cos of 58 is 0.5299. Now, there are lots of decimals. The more decimal places you go to, the more accurate your answer will be. So try to go to at least 4 decimal places. So in the next line here, we can add 1024 plus 1600, and we will get 2624. And we can multiply our 2 and our 32, our 40, and our decimal 5299, and we get 1356. Decimal 544. Subtract 2624 by 1356.544, and you get 1267.456. But we are not looking for A squared, we are looking for side A. So we square root both sides, and we end up with 35.6 approximately. The question asks us to put it into the nearest meter, so we need to write it as 36 meters. In this next example, we want to find the value of theta. So that means we're looking for angle, and in this case, theta is for angle C. So we can label these other sides. This would be C, A, and B. Now, because we are looking for angle C, we are going to use the version of the cosine law that starts with the C squared. And we are going to substitute the values that we know. We know that C is 5.9, A is 6.2, B is 2.3, and we are looking for cos theta. We don't know what that is. So we can go through now and calculate the squared parts. 5.9 squared is 34.81. 6.2 squared is 38.44. 2.3 squared is 5.29. Now we're going to treat cos theta just like we would treat it as a variable. So if that was a variable x, we would simply multiply 6 times 6, or 2 times 6.2 times 2.3, and we'd get 28.52 cos theta. So it's just like a variable. We can add our 38.44 and our 5.29 together. So we'll have 34.81 equals 43.73. Subtract 28.52 cos theta. So we're trying to get cos theta by itself, just like if you had a variable x. So we go through our process of solving a linear equation. We're going to subtract 43.73 from both sides. And we will end up with negative 8.92 equals negative 28.52 cos theta. So now we want to get the cos theta by itself. So we are going to divide by negative 28.52. And we will end up with 0.31276, etc. Again, the more decimal places, the more accurate you'll be. Go to at least 4. Now here comes a part where we need to recall back to Math 10 when we were doing sine, cos, and tan. If you are looking for the value of theta, how do we use our calculator to find this? We need to use our inverse of cos. And so a lot of times that is in the second or the shift on your calculator and then your cos button. Again, make sure you are in degree mode. So second function cos, 0.31276, and you get 71.77 equals theta. It doesn't tell us what to round this to, so we could leave it like this. You could write it as 71.8, or you could round it to 72 degrees, but it did not specify. In this example, we have a 3-pointed star is made up of an equilateral triangle and 3 congruent isosceles triangles. Determine the length of each side of the equilateral triangle in the 3-pointed star. So here's our equilateral triangle. Equilateral means all 3 sides are the same. So we want to determine what that side is. So we are really looking at this triangle right here. It is not labeled. We can label it. And it really doesn't matter which sides you choose to be A, B, and C. But once we've labeled the angles, you make sure that the opposite sides are labeled accordingly. And so the way that I have labeled this, we are looking for side A. So we are using this version of the cosine law. So now we can substitute the values that we know. B will be 60, C is 60, and angle A is 20. 60 squared is 3,600. So we have 3,600 plus 3,600 minus 2 times 60 is 7,200. And cos of 20 is decimal 93969. Now you could do that all in one step. I am simply breaking it up in case your calculator is not in degree mode. It's a lot easier for you to find your mistakes. Cos 20, you need to get decimal 93969. If you do not get that, you will make a mistake. So now we will have 3,600 plus 3,600 is 7,200 minus 7,200 times 0.93969 is 6,765.768. Subtract those two values. You get 434.232. Square root of both sides. And you end up with A equals 20.84. Now in this one, the question did specify how long to round your answer to, the nearest centimeter. So we are looking at 21 centimeters. All right, here's one where the diagram is not given. We want to solve the following triangle, and solving the following triangle means find all missing parts. We want to round all answers to the nearest tenth of a unit. So we have triangle XYZ. Side X is 5.2, so opposite angle X. Side Y is 4.0, and side Z is 4.5. So the missing parts in this one are all of the angles. So we need to find each of them. Pick one to start with. It really doesn't matter. I will pick angle X to start our process. So therefore, we are going to be looking at x squared equals y squared plus z squared minus 2yz cos x. And if you are unable to transfer the cosine law from a's, b, and c's to x, y's, and z's, simply relabel this as a, b, and c. And you will be able to substitute in what you need to know. So x is 5.2, y is 4, z is 4.5, and we are looking for x. So 5.2 squared is 27.04, 4 squared is 16, 4.5 squared is 20.25, 2 times 4 times 4.5 is 36, so we have 36 cos x. 27.04 equals 36.25 minus 36 cos x. So we are going to solve for x. So we need to subtract the 36.25. We'll have negative 9.21 equals negative 36 cos x. So now we divide both sides by 36, and you will have 0.25583. And then we do the second function cos. So second function cos, decimal 25583. And we get 75.2. They wanted the nearest tenth is angle X. So 75.2 degrees. But we have to find the other two angles. So now we have to choose another one to solve for. And again, it doesn't matter which way you go. You can choose to find y or z. So I'm going to look for y now. So I'm going to have y squared equals x squared plus z squared minus 2xz cos y. And I'm going to substitute the values that I know. So y is 4, x is 5.2, z is 4.5, x is 5.2, 4.5, cos y. So we have 16 equals 5.2 squared is 27.04, 4.5 squared is 20.25, 2 times 5.2 times 4.5 is 46.8 cos y. 27.04 plus 20.25 is 47.29. Solve for cos y, so we're going to subtract the 47.29. So negative 31.29 equals negative 46.8 cos y. Divide both sides now by negative 46.8. And you will end up with 0.66859 equals cos y. Remember to do second function cos. and then your value, and you will end up with 48.0 equals y. So what we will have is we have angle y equals 48 degrees. Now think about it. Do we need to repeat this process to find angle z, or is there another way? And hopefully you will remember that all three angles add up to 180. So angle z will equal 180 minus 75.2 minus 48. So angle z is 56.8 degrees. All right, so to sum this up, the cosine law can be used to determine an unknown side length or angle measure in an acute triangle. The important piece of information is that you are given two sides and then either the side or the angle opposite the side depending upon what you are looking for. You can use the cosine law to solve a problem that can be modeled by an acute triangle when you know two sides in the contained angle or all three sides. The contained angle is the angle between the two known sides. And when using the cosine law to determine an angle, you can substitute the known values first, then solve for the unknown angle. You can rearrange the formula to solve for the cosine of the unknown angle, then substitute and evaluate.